Welcome to the world of subatomic particles. In today's video, we will explore neutrons and their antimatter counterparts. Yes, neutrons and their antimatter counterparts. You know matter and antimatter. The matter is dominating in our universe, that is known to you. So if you talk about electrons, protons, neutrons, then you can easily find that electrons are negatively charged, protons are positively charged, and neutrons are electrically neutral. Neutrons are known as neutral particles. Question is since neutrons are electrically neutral, do they have their antimatter counterparts? The answer to this question is yes. Though neutrons are electrically neutral, still they have their antimatter counterparts. So let's talk about first electron. Electrons are negatively charged, and we know that positrons are antimatter counterparts of electrons. Electrons are negatively charged, so positrons are positively charged. Again, if you talk about protons, so you know protons are not actually elementary particles. Protons are made up of quarks. 3 quarks are there. 2 up quarks are there and 1 down quark is there. Okay, neutrons, same thing. In case of neutrons also, there are 3 quarks, but difference is there. Both protons and neutrons are made up of 3 quarks. Still they are different because quarks are not same. All the quarks are not same. Quarks come in 6 flavors. Yes, quarks come in 6 flavors: up, down, charm, strange, top, bottom. So total there are 6 quarks. So if you talk about only protons, not neutrons, okay, only protons, then protons are made up of 2 up quarks and 1 down quark. For each up quark, the electrical charge is plus 2 by 3. The electrical charge for any up quark is plus 2 by 3, and for down quark it is minus 1 by 3. So any proton, means if you talk about only one proton, then that proton is made up of 2 up quarks. So what is the total charge? Plus 2 by 3 plus 2 by 3, that is 4 by 3. And 1 down quark is there, so minus 1 by 3. So plus 2 by 3 plus 2 by 3 minus 1 by 3. What is the result? Result is 1 plus 1. Result is plus 1. So protons have, they are positively charged and unit is 1. Okay, that is known to you. In case of neutrons, if you now talk about neutrons, then neutrons are also made up of quarks. But there are 1 up quark and 2 down quarks. Okay, 1 up quark and 2 down quarks. Then what is the total electrical charge? For up quark it is plus 2 by 3. And for down quark it is what? Minus 1 by 3. So what is the result? Plus 2 by 3 minus 1 by 3 minus 1 by 3. So it becomes 0. So you know that electrons are neutral. They are electrically neutral. So this way they are electrically neutral. Plus 2 by 3 minus 1 by 3 minus 1 by 3. So total charge is 0. Still they have antimatter. How this antimatter is possible? Because antimatter means what? Their quantum properties should be opposite to each other. Quantum properties. So whenever we are talking about quantum properties, that means here we are talking about quarks. So antimatter counterparts of neutrons are known as antineutrons, and they are also made up of 3 quarks, but all those 3 quarks are not quarks actually, those are anti-quarks. Yes, antineutrons are made up of anti-quarks, not quarks. That means in case of antineutrons, there are 3 anti-quarks. 1 up anti-quark is there and 2 down anti-quarks are there. So here again the electrical charge becomes 0. But whenever we are talking about quarks and antiquarks, then their electrical charges are just opposite to each other. Okay, so this way antimatter counterpart of neutrons also exist in the universe. Though you can see easily that, and the reason for that is different, because our universe is matter dominated. Means our universe is dominated by matter, amount of antimatter is very less. Still we can see antimatter counterpart of neutrons, that is antineutrons, in case of high energy supernovae, that is supernovae explosions. Okay, in case of high energy supernovae explosions, you might see an existence of antimatter. Again, in case of high speed particle accelerators like a large hadron collider, there also you could see the presence of antineutrons. Okay, but in the universe this is rare, and the reason for that is different. Actually, in case of Big Bang, the amounts of matter and antimatter created were just same. Okay, and the reasons are different. Why now we can see only matter? Means since most of the things we can see around us are made up of matter, not antimatter. But the reason is somewhat else. Anyway, in a separate video I will discuss those things also. Okay, here in this video there was actually question. There was a question. Question was what? Question was neutron is actually electrically neutral. So still whether they have antimatter counterpart or not. So answer to the question is yes. Still they have antimatter counterpart. Okay. Anyway, so this was all about today's topic. So this is the end of this video. Thank you for watching this video.